proof number 3. So to begin this proof, we start with 4 identical scalene triangles. We then rotate 3 of these 4 triangles. We rotate the second triangle to 90 degrees, we rotate the third triangle to 180 degrees, and we rotate the fourth triangle to 270 degrees. Before going any further with this proof, it's important to remember how to find the area of a triangle. The area of a triangle is equal to base times height divided by 2, or height times base divided by 2. To find the area of our scalene triangle, we multiply the base, b, times the height, a, and then divide everything by 2 to find area. The reason you divide by 2 to find the area of a triangle is because when you combine 2 triangles, you get a rectangle. And the area of a rectangle is base times height. To reassert this example, we look at combining 2 smaller versions of our scalene triangle. When they're combined, they form a rectangle, and the area of this rectangle is equal to height times base, a times b. This is why we divide by 2 when finding the area of a triangle. Going back to our 4 identical rotated scalene triangles, we now see how they come together to form a square. One goes there, one goes there, one goes there, and one goes there. This effectively forms a square, the square seen in yellow, with a side length c. So, how did we derive the Pythagorean theorem from this square? Well, the first thing we need to do is find the area of the yellow square we've created. The area of the yellow square is equal to base times height. So, the height and the base are both c. So we have c times c is equal to area. This can be simplified to simply c squared. Now remembering the Pythagorean theorem, a squared plus b squared equals c squared. So we now know that the parts that make up the area of the yellow square will all be equal to c squared, which is part of the Pythagorean theorem. Therefore, the area of the 4 identical rotated scalene triangles and the area of the small blue square within the yellow square combined will be equal to c squared. So now we need to find out the area of the blue square and the 4 identical rotated scalene triangles. To find the area of the blue square, we must first determine side length. The side length of the blue square is equal to the length b minus a, the height. Now that we know the side length, we can find the area. The area of the blue square is equal to its side length times its other side lengths. So base times height, in this case they're equal. So b minus a times b minus a is equal to b minus a squared. Now that we have the area of the small blue square, we need to find the area of the 4 identical rotated scalene triangles. Because they are all identical, we can use one equation to find all 4 of their areas combined. In doing this, we remember how to find the area of a triangle. Because there's 4 of them, we do 4 times base times height, or height times base in this case, all divided by 2, because triangles are half of a rectangle. This can be simplified to simply 2 times height times base, 2 times a times b. Okay, now we know that if we combine 2 times a times b with b minus a squared, it's all going to equal c squared. So we have this. This can then be simplified out by just squaring a minus b and multiplying a minus b times a minus b, which gives us a squared minus 2ab plus b squared plus 2ab. The minus 2ab and the positive 2ab then cancel each other out, and we're left with a squared plus b squared equals c squared. This may look pretty familiar because it is, in fact, the Pythagorean theorem. So, we've now shown how the Pythagorean theorem can be derived. Good job.